Hello everyone, today in this video, I will discuss the correlation and regression. In statistics, to determine the relationship or connection between the two variables or measures, we will use the correlation. For example, you want to know if there's a relationship between the number of years of school completed and average annual salary. You can use the correlation for you to test the hypothesis. But how can we determine the correlation between the two variables? We can determine the correlation between the two variables by using scatter plot and correlation coefficient. Scatter plot, it is like what we have learned in algebra before by plotting in Cartesian plane. So here, we have an ordered pair, the x and y, wherein the variable x is the independent variable and y is the dependent variable. What's the difference between the independent and dependent variable? Independent variable, this is a variable that can be controlled or manipulated and it is plotted on the horizontal axis, while the dependent variable, this is a variable that cannot be controlled or manipulated, plotted on the vertical axis. Now, what is the purpose of the graph? It is to determine the nature of relationship between the variables. It may be positive linear, negative linear, curvilinear, or no relationship. When we say positive linear, it refers where two variables increase together in a linear pattern. Negative linear, as one variable increases, the other decreases. Curvilinear, it is not a straight line. Instead, the relationship changes direction at some point, forming a curve. And no relationship, it means that changes in one variable do not predict changes in the other. Let's have an example. Construct a scatter plot for the given data. In first row, the data for age, and the second row for the pressure. If we draw, label, and plot each point on the graph, this is how the graph looks like. Next one, to determine the correlation between the two variables, we will use the correlation coefficient. Correlation coefficient, it is just a number that describes how close to a linear relationship between two variables. And here, this is a formula of correlation coefficient, where n is the number of data pairs and ss is the sum of squares. The range of correlation coefficient is from -1 to +1. If the value of r is close to +1, it is a strong positive linear relationship. If the value of r is close to 0, there is no relationship. And if the value of r is close to -1, the relationship is a strong negative linear. Example, a statistics professor at a state university wants to see how strong the relationship is between a student's score on a test and his or her grade point average. The data obtained from the sample follow. In first row, we have a test score or x. Second row, the grade point average or y. Here, in the first column, the subjects. Second, test score. Third, GPA. Fourth, the value of xy. Fifth row, x squared. And sixth row, y squared. In finding the value of xy, we have to multiply the value of x and the value of y. In x squared, multiply by itself the value of x, and y squared, multiply by itself the value of y. Now the sum of x is 832, y is 22.1, xy is 2321.1, x squared is 86,890, y squared is 63.83. Now, we just substitute those values to get the value of r, and the value of r is now 0.716. Let's proceed to regression. It is a statistical technique that relates a dependent variable to one or more independent variables. As you can see here in A, B, and C, the regression line slopes upward from left to right, while D, E, and F, the regression line slopes downward from left to right. Here's the formula for regression line. Y prime is equal to A plus BX, where B is a slope and A is an intercept. Let's have an example. Find the equation of the regression line. The values needed for the equation are sum of squares of x is 362, the mean of x is 104, the sum of squares of xy is 22.7, and the mean of y is 2.76. Substitute the formula of b and a. The equation will be y prime equals negative 3.792 plus 0.063x. Now, let us discuss the standard deviation of errors and coefficient of determination. What is standard deviation of errors? It tells how widely the errors and the values of y are spread for a given x. It is calculated given below. Example, a researcher collects the following data and determines that there is a significant relationship between the age of a copy machine and its monthly maintenance cost. Find the standard deviation of error. Let's have three columns. First column for machine, second for age, third column for monthly cost. Here is the solution. Multiply the value of x and y to get the summation of xy of 14,380. Then multiply by itself the value of x to get the summation of x squared of 55. And to get the summation of y squared, multiply the value of y by itself. And the standard deviation of errors will be 148.05. And the last is the coefficient of determination. It is a measure of the variation of the dependent variable that is explained by the regression line and the independent variable. This measure determines how good the regression model is. The symbol for the coefficient of determination is r squared. Here is the formula of coefficient of determination. In this example, using the data in the previous example, the value of the coefficient of determination will be 0.769. Thank you.